let's go through this thing right quick. See if we can get y'all here.
I can get that G dot in there.
You got it?
For real, you gonna get that thing?
I'm gonna try my best.
Sensing wire voltage drops. What they're talking about here is sensing wire voltage drops, increasing the system voltage by the amount of the drop. What in the Sam Hill are they talking about? Are they talking about a sensing wire voltage drop? What is a sensing wire got to do with anything in a charging system? Do you know? Sensing wire? Okay. What is the charging system? It's got to keep the voltage at a certain level, doesn't it? In other words, if it doesn't know what the voltage is it going to overcharge sometimes maybe? Boil the acid out of the battery?
Yeah.
It could do that, couldn't it? So your voltage regulator, whether it's in the PCM or whether it's in the alternator, is going to, and you call it an alternator if the voltage regulator is built in. If the PCM's controlling it, you call it a generator, right? Remember that? Okay, your voltage, your sensing voltage in a voltage regulator, and this basically is going to come like on that Ranger out there. If you're going to put that Ranger, you got a yellow wire, and that yellow wire is going to B+, and it does two things. That yellow wire feeds the alternator field, which is the spinning rotor. It feeds the rotor, and furthermore, the electronic circuits in that regulator are going to measure the battery voltage. If the battery voltage is up at about 14.5, it's going to stop giving it so much magnetism. It's going to level that charging system voltage out at whatever the regular. Sometimes it'll be 13.6, sometimes it'll be 14.5. You know, it's just on different vehicles, different amounts, but you can tell if you connect. Listen up. You connect your voltmeter to a battery when the charging system's working, and it's reading like 12.5 volts. You know that you've either got a weak charging system, a load on the battery, or something, right? This B+ goes through some connectors, let's say, and it goes over here to B+ by way of a fuse usually, you know, so B+ will be over there. All right, if for some reason I've got a dirty connection right here, all right, let's say that right here, if I was to measure right here, well, let's say I went from here all the way to there, and I'm putting it here just to make it convenient, and let's say I got a voltage drop of 1.5. Okay, and let's say that up here I've got 14.5, and down here I'm only showing 13. Why am I keep making a B when I'm at 13 volts? Because I've lost 1.5 here. The voltage regulator is going to be confused into thinking that it needs to overshoot. Got me? That makes sense?
Yeah. So you got a cut in the wire or something, man?
Well, they're like a dirty connection. Hello? Hey. Yeah. Right. He can come up here, but right now I'm in class. But the point, this is a sensing voltage. You know, and this being your, you know, on the back of the alternator on that Ford, you got a voltage regulator, and it's got a couple of screws that are exposed here, and one I'm gonna say ground here to test and all that stuff. It's on the Ranger. You know, you got another one, and it may not be in exactly this order because you know I don't remember, but the other one goes where? Through the light, right? And then there'll be a little resistor jumping around that light, because you remember what I told you, if that light's not working, then the charging system won't even operate, because the power coming from B+ through that light turns that regulator on. Just like any other device, it's got to be turned on. And then this third wire is a black wire with a white strap that jumps around to a 7-volt output on the alternator. That tells this to turn off that light. But here is the question we're talking about. You drop in voltage on this sensing wire, you're going to have an overcharged condition, because it's going to believe charging system voltage is 13 volts when it's actually 14.5. And you may see what? What are you going to see up here if this is 13? It's going to fulfill it, and you maybe see 18 volts up there at the battery. You may be blowing both of your headlight bulbs and causing some battery acid boiling and all that. So everybody needs to be really sure of that. Just answering a question without understanding why the answer is what it is. Now, what did your book say about that, Amanda? Did your book say anything a lot about sensing sensing wire voltage?
Um,
I mean, did it go through it the way that I just did?
no.
Okay. This is the reason I'm telling you this is because I've run into that on vehicles before, where the sensing wire voltage would cause each alternator to overcharge. It makes you think there's a bad voltage regulator, but if I measure the voltage right here and I'm not seeing voltage that's equal to what I'm getting at the battery, then I've got a voltage drop condition in between there. If the output current is greater than needed, system voltage will fall below specification. Incidentally, the first one was true. But does that next one make sense? The output current, meaning how much the alternator is putting out. If the output current is greater than needed, the system voltage will fall below specification. Is that true or false?
False.
That's false, isn't it? Ma'am?
When it goes over specification.
Yeah, if it's greater than needed, the system voltage is going to be high. In other words, that's what I was talking about before. If this right here, you're going to get more output current if it doesn't know, and it's going to jack the voltage up, because the big terminal on the alternator, which is down here somewhere, the big post that's going directly to the battery, that's the one that's going to be putting out all the extra current. You're going to have high voltage if you got output currents greater than needed. In other words, if the alternator's putting out too much, your voltage is going to go really high. That's just the way that is. So number 2 is false. The battery cable should be disconnected before removing any electrical unit. That is true, but almost nobody does that. And I will tell you something else. If you're working on a dadgum Honda car, you better know the code for that radio before you pull that battery terminal off.
The code for the radio?
Yeah, because it'll lock it out, and you got to have a little 5-digit code that you get from Honda to punch back into that radio to wake it up, because it's a code.
Oh.
On the day. It's to keep people stealing radio.
Oh, okay.
That's what that's for. But pay attention to that. They got these battery saver things that you can plug into the lighter, but that's only good if the lighter is hot all the time, and that's also only good if that circuit is, continuous with the.
They tell you that when you buy a Honda like that from the dealership or something?
Well.
Yeah, they give you a 5-digit code that you gotta put somewhere in the vehicle.
Yeah, it's like a little card or something. Most people forget that.
Yeah.
And I tell you, I don't know the ones I pulled out that somebody had written the code on the radio.
Yeah.
Just in magic marker and all. Did y'all have trouble with that before?
Mm-hmm.
Where you had to punch in the code?
Yeah.
Sensing voltage is a voltage that tells a regulator just how much field current is necessary.
True.
That's true, isn't it? That's what I was talking about up here. The AC generator's maximum available output increases as rotor speed increases. That's true too. The more you rev the engine up, the more it puts out, right?
Right.
An alternator, this little sucker right here, as it's spinning, it's got to be able to put up with something like 14,000 RPM without coming apart.
Yeah.
Which is, it's got a little pulley, and the crank pulley is this big, this pulley's this big, so you're going to multiply. You do the math. If this pulley's a third the size of that one, and you're turning 5,000 RPM with this big pulley, you're screaming with that
You
alternator.
get smaller pulleys to give you more horsepower.
Yeah, instead, they got what you're talking about underdrive pulls, no. Technician A says before performing a voltage output test, a visual inspection and preliminary check of the charging system should be done.
I would.
You think you like that guy? I think he's pretty sharp. Technician B says a voltage output test will indicate if the charging system is working properly. He's more or less correct, but you can. I mean, if you put a meter to it and you see 14.5, you can have a pretty good idea. Now, if I hook the alternator to it, the voltmeter to the battery, directly to the battery, and I turn on all of the lights and the blower and the wipers and all that stuff, and the boom box in the back that the guy's got, the big thumping bumping thing gets you in trouble with the cops.
Yeah.
If you turn all that stuff up really high, and then I see this voltage starting to drop off, he may have more of a load at idle. I'm talking about idling.
Mm-hmm.
He may have more of a load at idle. And people cruise around town on the Friday night or something. They might find themselves with a dead battery over there somewhere because they're drawing more out than the alternator's putting out when it's idle. They're puttering around Dairy Queen and all this stuff. Not going too fast. So, but mostly, for the most part, there's the answer to that question, according to the answer here is C. You need a heck of a lot more than just a voltage at the battery test in order to check a charging system the right way, though. There's a lot you can do with a voltmeter, but you better be able to measure current, too. A 100 amp AC generator produces 105 amps all the time. I guess it's whenever they're testing, right? Full fielding it produces 105 amps also. What does this indicate? A, the regulator is running the AC generator full field all the time. B, the AC generator is faulty. C, the output wire has excessive resistance. Or D, the drive belt is slipping. Well, it must be working pretty hard. I'd say we probably got a regulator issue there. I will tell you this, though. I have seen them where the centrifugal force of this thing spinning would cause it to full field, even though the regulator wasn't doing anything. And this question doesn't address that. It's not a norm, but I've seen it. And I got smacked around by a motorhome. Revved it up, went to 18 volts. Oh, crap, that's a regulator. I know what that is. So I get a regulator from parts, pop it on there, rev it up, full field. Crap, what is this? And I didn't rev it up very much. Just give it a little bit of gas. And something in here centrifugally caused it to full field itself. Because, you know, whenever you got power here and ground here, it's full field. I got power and ground this, make a really strong magnet. You know what I'm saying? And but anyway, that's what this thing was doing. It was full fielding itself. But the right answer on that one is going to be A. What components make up the AC generator field circuit? Field circuit being the part that creates the magnetism, right?
The regulator, the stator, and the rotor.
The regulator, the stator. Is that right? Everybody like that? Like his answer? The field circuit. What about the battery, the rotor, and the regulator? The stator is not part of the field circuit because you're actually creating current in there. But that right there is number 8. That's going to be C. Technician A says when testing the voltage output, if the charging system voltage is too high, the cause could be an open field wire from the regulator. An open field wire, what does that mean? The field wire is how the field is controlled, isn't it? If I got this neon out here, and I got the 2 little screws on the back that they're exposed back there on the back, you turn on the key, automatic shutdown relay, powers up the field, the PCM dithers a ground into the other side of that, and that's how it controls. If I cut that field wire, am I going to have any alternator output at all? No, I'm not. Okay. So technician B says a loose or glazed drive belt could be the cause of too high charging voltage. These guys are both a couple of yo-yos. You're going to have a slipping belt that's going to make it charge too much? That's not good, is it? Technician A says a shorted diode may be indicated by whining noise. Technician B says a squealing noise may indicate a loose belt. Who is correct? All right, but what about the whining noise? Did you know that a diode can make an alternator whine? Make it sound like bad bearings?
Oh, yeah. Possibly.
You ever heard that before?
Nah, not yet.
Yep. All right. Got that? A whining. You heard a ceiling fan, haven't you, Lawrence?
Mine does that.
Wom, wom, wom.
Yeah.
If you've got that kind of noise, that's a magnetic resonance that's causing those windings to make that, noise.
My ceiling fan, that one, when you turn it on,
Uh-huh.
and you pull the cable down for it, it starts spinning, had to get like a little push off in it.
Well, my daughter was a little girl. I used to horse around with her. We had high ceilings, and we had 6-bladed ceiling fans in that old house we lived in. And boy, those things spun really fast. Little 36-inch Emerson things had a motor on this big around roll.
Yeah.
And I'd click that thing on, and I'd say, okay, Kelly, I'm going to hold you up into this ceiling fan. It's going to chop you up into bologna. I'd be holding her up, and she used to be hitting me on. Let me grab something right quick.
And more or less, so the ceiling fan don't work. It's hot in here. So, yeah. Just kicked it off. It's been good.
This alternator right here is off of a Lexus. It's a brand new alternator. Never has been on a car. You notice the pulley's shiny and all that stuff.
Mm-hmm.
Okay. Inside, remember some of y'all, I showed y'all how you can take your diode check on your meter and hook from here and then switch around. In other words, if you hook from here to here with it on diode check and you read about, 600 and something, the reading is not as important as whether it reads or not, really. And then you swap them around and it doesn't read at all. That's good. If it reads both ways, it's bad. If it don't read either way, it's bad. You got to make sure by touching your leads together that your diode check thing is working like it's supposed to. And this is something I always try to bring in. If I take my meter, and we've done this before, take my meter like this. Ben, I need some hands. Around here. All right. Hold that alternator right there because the camera needs to see it. Okay. All right. Now then, if I hook my diode check up to the housing, can we see the meter? What are we reading?
670.
We're reading 6 something, aren't we? 600 something, right? All right. Now if I swap my leads around, I hook the black one to the housing and the red one to there. Good that I got somebody as strong as Ben up here to hold this darn thing. All right. See that? Now it's empty. See that? Now if it reads the same both ways, you know that the diodes are bad. Now this is the kicker. Watch this. That's a rectifier bridge out of an alternator. This is the big terminal that the power comes out of. You notice how it's insulated from that plate right there? Mm-hmm. All right, since it's insulated from that plate right there, we know, and also we got these little screws right here that go on that hook into the housing on the alternator. We know this plate is ground and this plate is hot. Okay, we've also got these 3 little connections right here. And those 3 little connections are the ones that the stator connects to. There's 3 wires coming off the stator, and it's going to connect to that on this particular rectifier. It's a brand new one that's never been in a unit. All right, it's pretty cool. And these little round things you see the little dimples right here? These are diodes. These are negative diodes, and these right here in this plate are positive diodes. All right, you notice the negative ones are actually going through a hole in this plate that's pretty big, so they don't touch anything, and they have to isolate that stuff. Okay, so this right here is going to be totally hot. Ordinarily. So if you look, this particular output is connected to the positive and negative diodes. You might notice on your schematic how it shows it coming in the middle of the diodes pointing in both directions. That's what you're actually seeing in the real world. Okay, so if I was going to check this the same way we check the alternator, the way I would do that is I would take my terminal here, I would take the ground and hook it there, and I would take the hot and hook it here. See, the meter is not reading anything. All right, if I swap those around and hook them up like that, you see, now I'm reading something. Got it? Mm-hmm. You understand what I'm saying? You're doing the same job. The part that you're checking, when you check that alternator way I just showed you, is this piece right here. It doesn't look the same on every alternator. See that one over there on the wall? How it's almost a full circle, that little horseshoe on the bottom? That's what this is. They look different. This is the rectifier bridge. That's what it is. I've got little rectifier bridges. I don't know if I got one in here or not. But I got little rectifier bridges and little square things. And I can hook AC current in 2 sides and DC comes out the other 2 corners, you know. I get those from Radio Shack. It don't cost very much. But the fact is, that's a rectifier bridge. So always remember that that's how you do that. And I'm going to tell you, if you go up to a mechanic somewhere and you hand him a meter like this and then say, how can you tell me if the rectifier bridge is good or not? You know, it's a go. Like I say, I always like a go, no-go test. Now, just because this measure is good in one way and not the other way doesn't mean that alternator is good. All you're checking is one part of it. See what I'm saying? However, let me go this far. If you check it and it reads both ways or doesn't read either way and you know your meter is good, then that alternator is either going to be rebuilt or replaced. See what I mean? So you might check it and get good readings. That doesn't mean that the alternator gets a clean bill of health. It just means the rectifier bridge is reading like it's supposed to. You understand what I'm saying? All right. Remember that. You know, and that's. I used to get the parts house to send a bunch of bad alternators over here. They let me borrow them from their core bin so that we could check them and see what they look like. You know, see how they work. And I ought to do that. See if I could do that today or sometime this semester. Because we're running out of time. We're going to get our worksheets done. We're going to, you know. Anyway, the charging system of a vehicle is producing 100 amps and 12.4 volts at 1500 with all electrical accessories turned on. All right, now where am I measuring that 100 amps? Am I measuring it? I mean, I've got an inductive lead. I'm on question 11. Did I already do question 10? Mm-hmm. Question 11. Where am I measuring it at? Where am I going to clip my inductive pickup? This inductive pickup here, this is actually a, you know, funky thing here that I'm going to use for demonstration purposes. All right. If I do right here, I got a battery, I got a post there, I got a post there, and I got a cable coming off of it there, I got a cable coming off of it there. Over here, I got an alternator with a big wire coming off of it, and it's going to ultimately go through a junction block or somewhere back to here, right? I'm just drawing that for simplicity. If I connect this around the one of these, all I'm going to read is what's making it to the battery. And I might not read even 15, 20 amps, even with everything, 1500 RPM is above idle and all that. But if I clip it around here, everything that alternator's doing is going to show up on my gauge. Even if it's not all making it here, even if it's going somewhere else, and it's being used other places. So I'm going to, every time I get a chance, and if I can, I'm going to measure it coming out of the alternator. Now, sometimes the alternator's buried, sometimes there's two alternators, like on some of these diesels.
Okay.
Right. But anyway, going to the battery, well, what if you got two batteries, like on a diesel? Yeah, I mean, there's some, you gotta be creative with your checking and all that. Don't go to sleep, Ben. All right, so right here, we're gonna hook around this. Whenever we're seeing how much make the battery, and we're gonna hook around that to see how much the charging system is putting out. You got that? Understand it? All right. Huh?
On the same line, it's closer to the alternator.
Well, actually, this line right here is going down to the starter.
Oh, okay.
And this line right here is going somewhere else before it ever gets back up here. I just do it straight over there.
Oh, okay.
Basically, usually what this is going to do is there's going to be a junction somewhere, and this is going to go up there, and then it's going to go somewhere else, and it's ultimately going to make it back here.
Mm-hmm.
And this right here is going to go straight down to the starter.
Okay.
See, it's usually the way that works. I mean, there's various different ways people do that and all that. But anyway, make sure you understand that. So, the charging system output spec is 110 amps. Technician A says the alternator needs to be replaced. Technician B says the electrical demand of the new vehicle may be exceeding, the capacity of the charging system. All right, so 100 amps, 12.4 volts at 1500 RPM. That pretty strong? I would not replace that alternator, not because of that. But what I would say is the second guy is right, because it's possible for that thing to put out more. I mean, in other words, to need more than the alternator can put out with all the accessories turned on. That doesn't usually happen over a long period of time. It can, and like I say, cruising around town on a Friday night, Technician A says when testing the charging system, the state of charge of the battery is not a concern. Oh boy, does he know what he's talking about?
No.
Okay. Technician B says battery must be checked before first testing the charging system. Check first before checking the charging system. Obviously, you need to know you got a good battery and it's good and strong. If not, you need to throw a charge at it. Technician A says a scan tool may be used to full field some alternators. Technician B says field current draw test indicates if there's current available to the field windings. Who's correct? That's C. Both of the guys are right. Because if the PCM's controlling the field, you can tell it to full field the alternator with a scan tool if you have one that'll do two-way communication, like our big scan tool will communicate two-way, but our little ones won't. They read a lot of good data, but they won't. They can't tell the thing to do anything. They don't have that software. All right. What does increasing the regulator field resistance mean?
Less output is desired.
Yeah, less output current's desired. In other words, the regular field resistance would mean, actually the little voltage regulator on this Ranger out here, and the ones that are easy to measure, you can put a scope on it, and you can tell that it's dithering that, So on some of the regulators, though, it slows the current down so that it doesn't have as much field current going to it. That's what we're talking about. You're increasing the resistance, so it's, you're increasing the resistance, and there's less current going to this, which means there's less current being produced. In other words, because your magnetism is not as strong. All right, let me see. Technician A says when testing, the ground side voltage drop should be less than 0.2 volt. Technician B says the total insulated system drop should be less than 0.7. Who's correct about that? I'd say C is right about that. I mean, everybody's right, both A and B. Where is the output of an AC generator created? Where is the current actually created that leaves the alternator? And remember, this is spinning inside of that. So where's the current actually being created? As you sweep the magnetic field over the windings of this stator and it's got this laminated core, that's where the current's created. Now it has to be rectified by going through the rectifier bridge, but that's where it's created at. The stator. Technician A says the regulator is if full fielding with the regulator lower than specified output. Yeah. Well, think about it. If you full field it, if you bypass the regulator and it doesn't put out as much, that's not going to mean the regulator's bad, is it? You're passing a regulator, right? Technician B says a full field test will isolate the problem if it's in the AC generator or the regulator. That's pretty much what you're after, isn't it, when you full field it. Anytime you bypass something, let me ask you this. What if I bypass the switch and the circuit works? But when I turn on the switch, it don't work. What do I know?
You got a bad switch.
Got a bad switch. That ain't complicated, is it? There was a guy that I knew named Tom Brown, and he was desperately wanting to be a mechanic, and he was going to diesel technology at night. I was working down in Sabine Pass, and I was about 20 years old at the time. And he was 28. And he would go out to one of the forklifts, and he'd check all the terminals on the back of the switch, and he wouldn't find any power anywhere. You know, the forklift wouldn't start. And he found no power at any terminal on the back of the switch, and he'd replace the switch.
Why didn't they replace the power source?
Exactly. There's no power coming to the switch. There's not going to be any power leaving it. And he just really couldn't get that. He didn't understand it. And so I'd go, I'll draw on the board, and I'd say, look, let's make this simple, Tom. If I've got a switch, and I turn that switch on, and there's nothing happening over here, if I check for power here and power here, and there's no power anywhere, how is replacing this going to do anything? I got to have power coming in, or power won't go out. And he acted like he understood me, because I was, those were all on chalkboard. We didn't have whiteboards in those days. But he never could get that, and the next time he ran into another one that had the same problem, he changed the switch again. I was so frustrated with him. He didn't have the aptitude for electrical stuff, no matter how hard I tried to teach him. I saw another guy that could just do anything, and nobody ever taught him nothing. So it's just, you don't ever tell. His name was Brown, too, and he was only like 18 years old, and he could fix any doggone thing. Just had it in him. He grew up in foster homes and everything. He's just amazing. Somebody took him under their wing, and they could have made him into a prodigy. All right. Let's see. Where am I at? 14? 17. Good. I'm moving fast. Technician A says the regulator is the cause. Okay. So that's obviously not going to be the first one. That's going to be the second one. That's going to be B. What device is used to rectify current in an AC generator? What device is? Diodes. And that's what these little dimples in here, you can see them, the little diodes there. That is a diode, but it's a lot smaller than what you're going to find doing this heavy-duty work. You might also notice that whenever these, one of the things that on the old GM cars, like on a Chevrolet Impala from like the early 70s, if you turned off the key and the alternator light stayed on, that meant you had a bad positive diode in the alternator. If you turn off the key and the alternator light stays on. I saw that a few times back in that decade, a long time ago. Let's see. So that's going to be diodes. What component carries a magnetic field current in an AC generator? Carries the magnetic field current. It's not the stator. It's not the housing. It's not the brushes. It's this, the rotor. Right? Technician A says a diode should be tested with a digital multimeter that has a diode test setting. And that's what we were talking about here. That's what's so cool. Even the cheapest little $10 meter has got a diode test setting right there. Got that? Okay. Technician B says when testing a diode with a digital multimeter that has a diode test setting, the meter should read approximately 0.6 of a volt in one direction and 0 when the leads are reversed. Now, I never typically worried about how much the voltage was it was reading. I just looked at it reading one way and not the other because it's not always 0.6 of a volt. Don't get confused somebody with throwing them numbers like that. Okay, but let's give him the benefit of the doubt. And I'd say 20 is what? What do y'all think 20 is? Both the guys right? Okay, here's some fill in the blank stuff. What tools should be used to ensure proper belt tension?
Belt tensioner.
What tools you use?
Belt tensioner. Does this seem like a no-brainer question here? Belt tension gauge. We've never used one of those here. And I'm going to tell you something else. Almost never do you need that if you've got, well, yes and no. If you've got a spring-loaded tensioner, the spring in that tensioner can be weak or something like that, and it can cause the belt not to be tight enough. Sometimes the tensioner goes to replace. Another thing that you need to consider too is, and this is a car killer. The tensioner, anytime you're changing the alternator belts, you better spin all those pulleys and see if any of them are making a racket. But if the bearing goes right, it locks up, the car is beside the road. I mean, that's it. Especially if it's driving a water pump. Okay, secondly, the belt tensioner, these little aluminum belt tensioners that spring-loaded ones that move back and forth, those things can pop without break. The aluminum cast part of it can just break without warning. And it sounds kind of dumb. I think on your Honda car, the belt is tightened by a little screw that moves the pulley, I think, if I'm not mistaken. Honda usually does it that way.
Like on the Jeep.
They don't use, yeah, like on the Jeep. The Jeep moves the power steering pump. Ben's going to get that thing running today, by the way. All right. No, moves on the Jeep. But on those kind where you have to move the pulley with a screw, you needed to know how tight is too tight. Now, they make a belt tension gauge, but I don't know one mechanic in 100 that uses one or even has one in his box. They both think they'd be eight, you know. If you don't over tighten it, because you'll burn something up. You know, you'll burn out bearings. But for that, here's something else. Whenever you got a belt off of one and it's driving water, feel of the water pump. You'd be surprised how many times you'll feel a water pump that's not leaking or anything, but it's starting to get loose. And that's something you can show your customer. Or some pump is need to be replaced because it's got thunk, 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 thunk. Can't, you know, sometimes it's buried in there, driven by the timing chain or something. It's hard to tell. But if you can get your hands on those pulleys down there with the belt off of, you better be spinning them and paying attention to whether they're sloppy or loose or anything.
So just on belt again.
Yeah, and if you're going to buy a belt tensioner, you know, I told this story before, but I bought a $79 Daco belt tensioner from Advanced Auto Parts and Enterprise when the one went bad on the Taurus I was driving. I could have got one from Ford for $51. You know, and the one that the Daco one that I put on there, I sold the car to my son Matt not long after that. And the Daco one, the pulley started getting crooked, and it started squealing the belt. And so he was going to spray just a little silicone on it, and as soon as that silicone touched it, the belt would jump off. Because it was, you know, the back of it's right against that pulley, and the pulley's a little cockeyed. Yeah. And I went down there and looked, and I said, that's no good. And so I had to get him a, you know, 50. And I went back to the people at Advanced Auto Parts, and I said, look, I've got a show here where walk in the store, buy over the counter belt tensioner from Ford was $51, and you charged me $80 for this one. Thought you were supposed to price match. And the guy said, well, that one for less than that I use, so I can't help you with that. Yeah. But I'd already made the buy. I'd already purchased it, so he had, you know. But anyway, the belt tension gauge is what you're supposed to use. If the solid-state electronic voltage regulator is not in or on the alternator, where would it be located? If the solid-state electronic voltage regulator is not in or on the alternator, where would it be located? Typically, it's in the PCM, right? Although, on some of the Ford cars, they would have a solid-state regulator mounted on the fender. You know, so that's just, I mean, some of these questions just don't apply to all cars, you know. All right. What's the name of the stationary coil that produces a current, an AC generator? Is it a stationary coil, you guys?
Stator.
That's the stator, isn't it? How many pairs of diodes does full wave rectification require in an AC generator? 3 pair. Now your stator comes together and you have diodes on both sides of it. All right. What the fault indicator circuit is completely ground in most electronic regulators if there's no output from what component? If the stator is not producing any current, it'll turn on the light. Now, I told you this before, and I like to say it again. I could take a car, you know, like my little Ranger out there, and had a short to ground, in there. Just short that wire that's going to the indicator light in the ground somewhere. You know, just pinch it to ground. Maybe Scotch lock it and put it back in the harness and tape it up. And I could carry that to shop after shop after shop after shop after shop, and every one of them I'll throw an alternator at it and then be mystified as to why it wouldn't put out. Because if that light's not working, you better find out why. The charge light, if it's on all the time, you know, most of the time it's the alternator anyway. But if it's on all the time, unplug the wires from the alternator and see if it goes out. If it does, you're pretty safe, probably the alternator. On the Ranger, if that little white wire that jumpers around from the 3-terminal connector to the 1-terminal connector, you know, you got these other 2 wires and you got one that loops around to a single wire connector, this comes off the stator. If this has got a bad connection or it's cut, our alternator will be putting out just fine, but that light will be on. See, they got to understand that too. So, something else I could do. I could cut the wire going to that little, if I shorted it to ground or if I cut it, the charging system wouldn't work on Ranger. And that's what you need to be aware of. I mean, you need to know how to think beyond throwing an alternator at it. Now, typically, Adam Snap was talking about, he says he knew some aircraft mechanics, you know, that would, and he was talking about one of them. He said all the guy knows how to do when the car won't run is he pulls the alternator and he goes to have it checked and he puts a new battery in the car. that's all he knew how to do. I don't understand that line of thinking, but that's what the guy did. Okay. And that concludes the test for today. Did y'all learn something that you didn't already?